Okay, hello, Kia. Let's do this.
Hello, sir.
Hey, Kia, how are you?
I'm getting you.
Awesome, awesome. All right, so we are still continuing on with our fight against quadrilaterals. Are you ready for the fight of your life?
Yes.
Oh, okay. All right. Hopefully you slept okay. Hopefully my network is okay. Can you hear me well?
Yes, I can.
Okay. All right. So the last time we did a few problems there that had to do with I think I gave you some game challenge problems, or let me say what they would say is homework. You looked at a trapezium. We looked at how to find x and y in a trapezium. And what's nice is that you sent me your work, so I was able to see what you did. Then we looked at the kite, how to find angles that are missing there in a kite, in a rhombus, in a rectangle, and in a parallelogram. So I think we even spoke about how it's important to also know, a few things about your triangle, because if we know that the sum of the angles in a triangle add up to 180 degrees, that can also help us out sometimes when there's a missing angle. Um, yeah, and then your relationship between parallel lines, we also emphasize that, which is important. And then, of course, your properties, when you know those very well, then it makes it easy for you to be able to find the missing sides and angles. So, hopefully, there's something there that we were able to take away with us. All right. So, let's look at this now. We've been focusing a lot on angles, but I think one thing that we have missed our focus on is the sides, if we are using the properties. So let's say we had the following: 2 centimeters, 4 centimeters, A and B. And that what they are saying here is find the missing side, giving reasons. Okay, and this here is a parallelogram. So Kia, what would be the length or the magnitude of A and B? And for each one, you need to give me a reason. So this is a parallelogram. What is A and what is B? Oh, snap. We lost Kia there. Yeah, I didn't even realize that we lost you there.
But I think B is also equal to 2 centimeter, and then A is equal to 4 centimeter.
Okay, you say B is equal to 4 centimeters. All right. And then you said B is equal to what? Sorry, you said B is equal to?
2 centimeter,
Okay, 2 centimeters. And then you said A is equal to?
4 centimeters.
All right. And what's your reason? Because you need to provide a reason.
Both pairs of opposite sides are equal.
Okay. Okay. So obviously we are identifying B. We are identifying a B there. Okay. I love the fact that you said both pairs of opposite sides are equal, because that speaks to the property that we had actually mentioned, right? But for B is opposite. Okay. 2 centimeters. So if we're looking at B alone, then you say B is equal to 2 centimeters, and the reasons opposite sides of a palm or a parallelogram are equal. Okay. Then same thing with the A is equal to 4 centimeters, opposite sides of a palm are equal. what you had said is also correct. Both pairs of opposite sides are equal. All right, so yes, indeed, you're spot on. Okay, so that's using our properties to basically state our reason. Let's look at this one. So this is
When,
B.
when we're doing the reasoning, do we have to write the name of the shape?
Yes, it would be good if you did, like if you specified, because you are referring to a specific quadrilateral. Okay, so it's always good to do so. Yeah, like opposite sides of a rectangle, if I was speaking about a rectangle. If it's a parallelogram, opposite sides of a parallelogram are equal. If it's a square and so forth, you obviously it would be right, it would be good and right to specify. That would be 100% fine. But remember what I said here. Always revert back to the notes and also the work that you did at in class, and then check what reasons did your teacher sort of like encourage you when you were actually doing it at school. So in as much as I am helping you right now, always try and align yourself, very closely to what your teacher specified you should write whenever you are doing such problems. So I don't know if from for instance from the notes that you have, when you were actually identifying a side that is opposite and equal for a parallelogram, what was the specific reason that you guys used when you were at school or in class?
I think, I think, I think we were writing the names of the shape also, because I remember in class and even inside my book there's where I wrote some of them.
Yeah, okay. Yeah. So then if you get that, then that's fine. You see, so yeah. Because at the end of the day, I don't want you to sort of like get lost in what I am saying, but I want you to sort of like use what I am saying as sort of like validation of what you were doing at school. And furthermore, then sort of like align yourself with what your teacher would specifically say to you at your school so that you can sort of like appeal to the way that she wanted things to be done or he wanted things to be done. Yeah. Yeah. Okay. So we can move on to the next one. So we have another one here. We are specifically saying this is a rectangle. And in this rectangle, we have B, we have A. So once again, I want the length of B and the length of A respectively here.
B is equal to A
Okay,
because
B is equal. Mhm.
because pair of opposite sides are equal,
Okay,
and A is equal to. Can I please see the shape again?
I'll do that for now. Yes.
Equal to 3 centimeters. No, 3 meters. Yeah.
Okay. I like the fact that you quickly saw that. That was kind of like a trick question. Okay, A is equal to 3 meters. Okay. And then the reason,
Is opposite sides are equal
okay,
of a rectangle.
yeah. So opposite sides of a rectangle equal, equal. Okay, spot on. All right. All right. So as long as we are able to recognize the shape that we are looking at, then we should always be on the good to go. 3. Okay. Excuse my going there and my error there, but this one is a square and we are given 5 centimeters there, and then we are asked to find the length of A. So what would you say?
A is going to be 5'2",
A is going to be?
5 centimeters.
Okay, reason.
Um, all four sides are equal.
Exactly. All four sides so of a square are equal. Right. So yes, you are spot on. A is equal to 5 centimeters. All four sides of a square are equal. Okay. Please align. You are blurry. You visual aid. I can't see you properly. Thank you. Okay. Next, 4. Let's look at this one. This here, okay, is a rhombus. Mr. Rhombus here, A and B. So,
A is equal to 6.
okay, A is equal to 6 centimeters. What's the reason?
Even all four sides are equal.
Exactly. Okay, we can even say A is equal to B is equal to 6 centimeters. We know that A is also equal to B, it's also equal to 6 centimeters as well. And we know that because all four sides of a rhombus are equal. No doubt. Okay. Right. Okay. That was not too shabby, was it?
No, it doesn't.
Okay. Let's let's extend our. Okay, let's say we have. Sorry here. Sorry. We have this diagonal, that diagonal. Excuse me for my free-handedness and the squiggly lines. They're not as straight. We have 2,5 here. We've got B here. We've got 1,5 there. We've got A there, and yeah, this here is a parallelogram, and we are required to find the length of A and B. Okay, AO is 2,5, DO is 1,5, and we're required to find the length of B and the length of A. Our dimensions are in centimeters. Okay, so
Oh, yeah. C is going to
sorry,
be
sorry. So A, D, B, and C are just simply your, they are the ones that basically denote your AC, your length, CB, BD, and AD. So we're not wanting this A, C, B, and D. All we want is this A here and this B there. So the length of OC, the length of OB. So the length of OB denotes A, the length of OC denotes B. So we want A and B. We are told that OA is 2,5 centimeters and OD is 1,5 centimeters. And all we want is the length of B, which is from here to there. You want the length of A, which is from there to there. So what would you say?
A is equal to no, yeah, A is equal to 2,5.
Okay, A is equal to 2,5 centimeters. I tend to want to agree with you. What's the reason?
Opposite sides are equal.
Okay, go back to your notes. Okay, remember what is AB? What do we call AB? AB is called what is the name? AB is called the NCD. We call these two dimensions AB, the length of AB and DC. We call these things the what of the parallelogram? What are they?
Is it angles?
No. Okay, you can go back to your notes for parallelograms. Okay, your properties. Okay, this actually speaks to your property of your parallelogram. But CD and AB are called, it starts with the D.
Diagonals.
We call these
Diagonals.
Diagonals, yes. Diagonals. Okay.
Oh, that's bisect.
Yeah. What did we say about diagonals of a parallelogram?
They
What do
bisect,
they?
bisect each other.
Exactly. That's why you were able to say to me, Sir, A is equal to 2 comma 5. Why are you saying A is equal to 2 comma 5? It's because Kia knows that CD, which is a diagonal, cuts AB into half. That's why you know that the length of A is 2 comma 5. But what is CD? CD is called the diagonal. What is AB? AB is called the diagonal. Okay. So when we say A is equal to 2 comma 5 centimeters, what is the reason for saying A is equal to 2 comma 5 centimeters?
The diagonals of a parallelogram bisect each other.
Thank you, Kia. Thank you, thank you, thank you. Sure, that was amazing. That was great.
Thank you, sir.
Okay. Diagonals of a palm bisect each other. Okay, great work. Okay, then we found A. We can officially update our diagram. Okay, I usually say to learners that whenever you are doing a particular problem and you find something and it's correct and you know it's correct and you know the reason and the reason is correct, you can then update your diagram and fill in what you have just found. Okay, now we want B here.
B
What is
is
B?
1.5 centimeters.
Exactly, B is 1.5 centimeters, and what is the reason?
Diagonals of a parallelogram bisect each other.
There we go. So don't ever forget that word, diagonal. You should just like go to your mother and just tell her that, Mom, you look like a diagonal. You try and use the word diagonal as much as you possibly can. Diagonals of a palm bisect each other. Sorry, I'm repeating the same thing here. You see? It's like now I'm trying to attach everything to a diagonal of a palm. Diagonals of a palm bisect each other. Okay, all right. That wasn't too shabby when I was it. Okay, so you see the importance of knowing the properties. If you know the properties, Kia, you're not gonna go wrong. But if you forget them, unfortunately, Kia, that's where the problem starts. The problem with quadrilaterals, just with any sort of geometry in grade 9, is that if you forget the properties, that's where things go south. Forget one thing, that's where problems start. Okay, so let's look at this. This is B, this is A. So once again, 5 comma 5, we have 3 comma 5, and we say that this is a rhombus. I want A, I want B. The dimensions are in centimeters again. So here,
Oh, B is equal to 5.5.
right, B is equal to 5 comma 5. Okay, reason?
Both pairs of no of opposite sides. Oh, the diagonals of a rhombus bisect each other.
That's okay. Diagonals of a rhombus bisect each other. Okay. Okay, you are spot on. Okay. Yeah. I think you keep on wanting to say opposite, eh? You
I'll have to remember when I say opposite, it's actually diagonal.
yeah, I understand. I understand. So you see the thing is it's this whole idea of saying what you mean. you say what you mean and you write what you mean. You don't sort of like write. You know what you should be writing, but then you don't write what you actually mean. And then it actually is the wrong reason. But you know in your head that you were trying to say, no, it's the diagonals, but then you say opposite side. So we just need to make sure that we don't ever make that mistake. And then the value of A, Kia?
It's 3.5.
Okay, awesome. A is equal to 3.5 centimeters. What's the reason?
Diagonals of a rhombus.
Okay, yeah. Tina will always be winning as long as we know our reasons. Know what they say, everything happens for a reason, Kia. Okay. Hey, let's move on, Kia. Let's move on. There's bigger fish to fry. Let's move on to the bigger fish. I'm sure you can tell me what this shape is without me actually telling you and labeling what it is.
Kite.
Oh, there we go. Looks like it definitely looks like a kite. Okay. Now I want to harass you, Kia, and find out from you what the length of A and B is. What can you tell me?
A is equal to 1.5.
Okay. Now I am very eager to know what is the reason for you saying that. So I expect you to check out your properties and then to actually go ahead and let me know what the value of A is. The reason for saying 1.5.
Is it adjacent something?
Okay, it is adjacent something. Now I want you to formalize it for me.
Pair of adjacent sides are equal in a
Okay,
kite.
thank you. Pair of adjacent sides of kite are equal. Nice. Yeah. Okay, Tasha in the comment section says adjacent sides of the kite are equal, which is also 100% spot on. Okay, then B, what about B?
B is equal to 4.4.
Awesome, 4.4 centimeters. What's the reason?
Pair of adjacent sides of a kite.
Yay, I. Okay. Aye. We are flowing right now. We're just killing it. Wouldn't you say? Our reasoning is just spot on. Our answers are accurate. We are accurate in the identification of the side, giving the right length, and then we're also accurate in our reasoning, which is what we want. Because if those two things align, then we are forever winning. We are not losing at all. All right. Okay. Here's another one. This is a rectangle. And all I want from you, Kia, is to I want you to give me the length of B and the length of A. So obviously this is B 2.5. This here is 2.5. This here is 1.8. And then I want A and B. So let me hand it over to you. This is a rectangle.
A is equal to 1.8.
Awesome. A is equal to 1.8. What's the reason?
Both pairs of opposite sides are equal? No. The diagonals is for B, right?
Yeah, very true. I like the fact that you realize that. So yes, the diagonals is for B. So what is the value of A? It's 1.8. What is A and 1.8? We call these, what are these for a rectangle? These are, this side is opposite this one. So A is 1.8. Our reason is
Both sides are equal.
opposite sides of a rectangle. Okay, so what you said basically, you said a pair of opposite sides of a rectangle. That's also fine. You said it correctly. Pair of opposite sides are equal. In a rectangle, the pair of opposite sides are equal. So you were right. Okay.
And then B is equal to 2.5.
B is equal to 2.5. What's the reason?
Diagonals of a rectangle bisect.
Thank you. Sure. Diagonals of a rectangle bisect each other. Bisect each other. Man, look at me. Don't ever do this. Don't ever have my habits here, Kia, where you start shading things in, and because you made errors, don't do this. This is just not good. Making too many mistakes there with my letters and so forth. Okay. All right. So this is very important that we know, okay, that, okay, 1,8 and a, these are opposite sides. They are of which shape? It's a rectangle. What do I know about the opposite sides of a rectangle? They are equal. Then with diagonals, what do we know about the diagonals? Diagonals, basically, of a rectangle, they also bisect each other, which is very important. And Tasha, you are 100% correct. For a rectangle, the diagonals are actually equal. So in other words, this diagonal from here to there, it's the same length as from here to there. For a rectangle, yes, diagonals of a rectangle are equal. So to answer your question in the comment section, definitely diagonals of a rectangle are equal. Okay, all right. Okay, I think let's try now and go back to angles. Okay, so I'm sure you can see what we were doing here, Kia, is that we were looking at the properties that relate to the sides. If you remember at the beginning, you and I looked at the properties that relate to angles. Okay, when we first started this live session together with Quadrilaterals a few days ago, we looked at the properties of the quadrilaterals first. After identifying the properties for each quadrilateral, then we did questions that have to do with finding the missing angle. And then that meant that we had to be spot on about the properties that relate to the angles for each quadrilateral. Now today we looked at the properties that relate to the sides and to the diagonals, okay? And we used the appropriate reasoning to be able to say this side is equal to this because of this reason that relates to the sides or the diagonals. Now I want us to go back a little bit to angles. Okay, I hope you're ready for this. 108 degrees. Oh, there we go. I hear you saying it under your breath. This is what shape is this?
The trapezium.
Yeah, it's a trapezium. Okay, let's see if my good student, the queen of quadrilaterals, still remembers how to find missing angles with regards to this trapezium. So, what is the value of x? What's the value of y?
I think D from angle D to C, like that, it forms a U shape.
Ooh, yo, look at you. Oh my goodness. I would like I literally feel like I'm so emotional right now. Amazing. Amazing. Okay. So you said from angle D to Y, it forms a U shape. Yo, I love you saying that. Like it touches my heart. Okay. So then, because it forms a U shape, what do you want to tell me?
Co-interior.
Yo, epic. So the relationship that exists between these angles is a co-interior angle relationship. What about co-interior angles, Kia? What do you know about them?
they equal to 180.
They add up to 180. Nice. They add up to 180. So, what am I going to write down?
180 minus
Okay. 180
minus 108.
minus 108. Mind you, this is the value of y. Y is equal to, so I need to obviously have that down. Y is equal to 180 degrees minus 108. What's the reason? Remember, we need to write down the reason.
Co-interior.
Exactly. Co-int angles. And then there's something we need to see immediately after we write co-int angles.
It's D. No. How do I put this? DC.
Okay.
No. AD is equal to parallel to BC.
Beautiful. Sure. Nah, I feel like now I feel like my work is done. My work is done. So AD, very good, Kia, is parallel to BC. So whenever we write the reason, co-interior angles, then we need to state the lines that are parallel. This makes this reason full and complete when we state the lines that are parallel after writing co-interior angles. Yo, Kia, are you a genius? I don't want to forget. The 180 minus 108 is equal to what, Kia?
72.
Spot on. And then your teacher can't help but weep. Like, literally, tears of joy. You know? It's like if you are marking a student's paper and you see such, like, beautiful, accurate work, it's like you can't help but be like, man, this student is just bringing joy to my heart. Okay, so that with the parallel lines and that beautiful answer at the end, 100%. So please keep it up. Let's move on. We want the value of x, the angle x.
X. Oh, we're going to there's like A and B. No, angle A and they form a U shape too.
Amen. Sure. Guys, I hope you're seeing how Kia is like, all those who are actually in the live. I hope you guys are seeing what Kia does. I love the fact that Kia first identifies the angle and is like, okay, the two angles, they form the U shape. Thank you so much. Then, what can you tell me further, Kia?
And it's like co-interior angles.
Awesome. So X and the A and the B, they have a co-interior relationship. What about co-interior angles, Kia?
They add up to 180.
Awesome. They add up to 180. I liked what somebody said in the comment section. I think it was Tasha, and she used the word they are supplementary. So this is like this big mathematical word. When we want to just say they add up to 180, in short form, we just say the angles, they are supplementary. Supplementary is just a big term that means they add up to 180 degrees. So in the same vein, it's amazing. Then what do you want to say further to me, Kia?
I'm not 60. No, actually it was co-interior angles.
Yes.
Add up to 180 and then
Yes.
180 subtract 60. Is it 62?
Yes. So 180 minus 62. But let's not forget to say x is equal to 180 minus 62 degrees. Our subject for the variable that we want to find is x, then we can simply write equal to 180 degrees minus 62. The reason?
Co-interior angles.
Thank you. Co-int angles for short, and then we state what after that?
The angles.
Okay, be careful. We state the. What is AD? It's a line. BC, it's a line. So we state the lines that are
parallel.
Exactly, parallel. So AD is parallel to BC. Then value of x here,
X is 110.
the 100 and
10.
be careful. Is it
Oh,
110?
sorry, I didn't see properly.
Okay, 180 minus 62. Just check that out quickly and then you can tell me what the answer is.
118.
Okay, 118. Okay. Okay. So statement, the reason with the lines that are parallel, and our answer. Okay, thank you, Kia. Kia, I'm so impressed. I'm impressed with the fact that you remembered the relationship that exists between parallel lines. These arrows, guys, these arrows here, they signify that the line AD and the line BC are lines that are parallel. And we know that the property, the distinguishing property about a trapezium is that it's got one pair of opposite sides that are parallel. So very, very crucial and critical, that understanding. Kia, well done. Well done. Okay, let's move on to the next one. I feel like Kia is on fire right now. It's so good to see. Okay, here we have this one. It's PSRQ. We have 50 degrees. We have X. We have Y. Here.
It's a rhombus, right?
This, we are told PQRS is a parallelogram. We are told that. So we are given that. Okay. Right? Okay, but I understand why you would say it's a rhombus, because you're not necessarily told the sides here if they are equal or not. It's like you're just given the lines that are parallel. Okay, but nonetheless, we want X, we want Y. So Kia, what are your thoughts?
180 minus 50? No. I said, wait, 180 minus.
So which angle are you finding? Are you finding Y or X? Okay, remember this is a parallelogram, so
X. Yeah,
okay,
X.
to find X. Okay, so what relationship X and 50 degrees? What do we know about these angles? Because if you're looking at X, then obviously you want to look at the given angle with X. What relationship exists between this angle and this angle? If you go to your properties for parallelograms, what do you know about the angles? These angles are actually opposite each other. What do we know about opposite angles of a parallelogram?
The diagonals.
The angles. Okay.
Oh, the angle.
Yeah. Okay. So Kia, this time round, you can see there's no line that connects the P and the R, which means we don't have the diagonals written or drawn. Okay.
The diagonals are only there when there's the lines.
Yes, Kia. Very importantly. Okay. So what we do have is the angle, the angle of P, which is 50 degrees, and we want the angle of R, which is X. So what is the relationship that exists between this angle of P, which is 50 degrees, and this angle that is X, which is R? Okay. If you go back to your properties, these angles P and R, we refer to them as opposite angles. This angle is opposite this one. So what do we know about the opposite angles of a parallelogram? If you go back to your properties, okay, what did we say about the opposite angles of a?
We said both pairs of opposite sides are equal.
Angles.
So angles. Both pairs of angles are equal.
Yes. Okay. So it's very important here that you take note of what are we looking at this time round. Okay, we are looking at the angles this time round. We are not looking at sides. Okay, so if we look at the angles, we want X. X is an angle. we are given angle P, which is 50 degrees. So we want to check now from our properties, what property would we be using so that we can,
Yes.
support what we are going to say about x. Okay, so you're saying now to me x is equal to what? I'm listening to you. X is equal to?
50.
It's equal to?
To 50.
Exactly 50 degrees. Why, Kia? You are spot on. This angle here, x, is 50 degrees. Why do we say so?
A pair of angles are equal in a parallelogram.
Okay, opposite angles of a parallelogram are equal. Okay, you're 100% spot on. Very, very true. So the opposite angles of a parallelogram are equal. Okay, all right. Then we can
Then
update our diagram and write in that 50 degrees so that we know it's there. Now we want y.
y is going to be equal to no the U shape.
Aha, yo, look at that. There's the U shape, right? And I'm sure you can see, Kia, that this U shape, this line is parallel, this line is parallel. But I'm sure someone else who's looking at this is also seeing there's a U shape in this side as well. Okay, look at my red. Okay. So it just depends what is your orientation. There's U shape and there's also U shape. Okay. So, okay, I'm listening, Kia. You tell me why I want why.
So yeah, it forms a U shape,
Okay.
which y is going to be equal to 180
Thank
minus
you.
50.
Very good. What's the reason?
Oh, um, cointerior angles
Exactly. Co-interior angles.
in the sides are no, yeah, yeah.
Yes.
PS is parallel to Q to QR.
Okay. PS is parallel to QR. So if you look at what you've just said, it means you are specifically looking at this U. Because you see where your U is, this and that, it's where PS and QR are. So you specifically said co-interior angles, PS is parallel to QR. So you are 100% spot on. If someone else had said they are looking at this U, right, they would have also been correct because this is 50 degrees, this is Y. And you can see that these two lines are also parallel. So if someone else would have said y is equal to 180 minus 50, co-interior angles, and then had said PQ is parallel to SR, they would have also been 100% correct because these lines are also parallel and these two angles form that U shape. Okay, so thank you so much, Kia. So what is our value of y then? Y is equal to, at the end of the day, 180 minus 50 degrees we get.
130.
Awesome. Kia, you are something else. You are something else. That brings happiness and joy to my heart. Statement, reason, answer. You see? We're not forgetting those lines that are parallel. Kia is always remembering those lines that are parallel, no doubt. Okay. I'm sure, Kia, you are sort of getting the flow of these problems. It's like it's becoming a little bit more and more second nature to you. And this is what we want at the end of the day, right? You are able to hammer in the properties as you do these like problems one by one, and you see, oh, okay, this was never supposed to have been a problem to begin with, but it's a good thing that it was, so that we can be able to now today look at it and see what we need to see. Okay, so here we have A, B, C, D. We have X there that we want to find. We have Y there that we want to find. And all in all, we are told that ABCD is a rectangle. So obviously, the minute they say rectangle, we are like now eager. We have a switch that comes on in our heads of like properties of a rectangle. Okay, so we here, X and Y. What are your thoughts? This is a rectangle.
Can I use is it the alternate thing? No.
Okay, so you are thinking of alternate angles, all right, and it's good to be thinking of alternate angles. Very, very good to be thinking of it. So what you want to establish first and foremost, which one can I find immediately? Can I find X immediately, or can I find Y immediately? So if you're thinking right now of alternate angles, okay, let's just explore this idea of alternate angles, because your head is thinking alternate angles. So these two lines, because I want to see, you see these two lines, AD and BC. We see that they are parallel, right? And I love the fact that you said alternate angles, because it means you are thinking of that Z shape, right? Angirikia. Yeah. But now let's see here. If we are thinking of alternate angles, it means X is equal to Y, but we don't know what the value of X is. We don't know what the value of Y is. So right now, even though alternate angles will probably be used later, for now, using that won't assist us to get the value of the unknown or the missing angle. Maybe someone else is going to say, okay, let's look at this alternate angles a bit differently. Let's look at the Z. Okay. And in geometry, we must do this sometimes. Turn around the shape so that we can basically make our point. Let's see the Z from this direction. You see, Moss? That means this 73 degrees is equal to this angle here, right? Still, that does not give me X, that does not give me Y, all right? So for alternate angles, okay, I think eventually it will assist me, but for now it won't. So let's look at our rectangle once again. Let's put alternate angles, on the side for now. We are going to use it later. Let's just look and see what can we find, which angle can we find, knowing the properties that we know about a rectangle. Okay, there's something that we should be able to quickly pick up about one of the properties that relates to the angles of a rectangle. Kia, do you have your properties like in front of you?
Yes, I do.
Do you still remember? So if you look at the properties that have to do with angles, there should be one that stands out, which should be helping you a lot.
Pairs of opposite sides are equal.
Okay, we are not talking about sides, we are talking about angles. So if you scan through the property, isn't there a property that speaks to angles or an angle of a rectangle? Something about the corner angles of a rectangle? Each angle in a rectangle?
I don't have that. I don't have it here.
You don't have it here?
No.
Okay, didn't we ever speak? I think I did actually write down. Let me just go back to the notes that I wrote down for you for the properties. Here it is. This was our rectangle, okay, if I remember very well. And then we said each interior angle in a rectangle, each corner angle in a rectangle is equal to what, Kia?
90.
Yes. Remember that one?
Yes, I remember it now.
Yes. So if we come here, there were some people that said it in the comment section. All right. Winter AWOL said each corner angle. Okay, let's be specific. Each corner angle is 90 degrees. That means angle A is 90, angle B is 90, angle D is 90, angle C in its entirety is also 90. So in other words, this here, this whole entire angle is 90 degrees, right? So that's where we start out there. This entire angle is 90 degrees. Okay, are you with me, Kia?
Yes, sir.
So we can say angle A is equal to 90 degrees. Angle A is equal to 90 degrees. What's the reason? Corner angles, or each angle of a each angle in a rectangle, corner angles of a rectangle. Okay. I think, yeah. I think I had said to you each interior angle of a rectangle is 90. Okay, so very important property that you see here.
Yes, sir.
Yeah, so that is 90. So if the total angle here is 90, I have this portion from here to there being 73, and this portion here being x. I want the value of x. What can I then say?
90. A is equals, no, X is equals to
Thank you. X is equal to
90 minus 73.
90 minus 73. And there's a reason why that is the case. These are complementary angles. When angles add up to 90, we say they are complementary angles. So for short, we use COMP, comp angles, complementary angles. Okay, so I'm just going to write this word complementary. Complementary means add up to 90. Okay. The the cousin of supplementary, which means add up to 180. Okay, so these are words to know. You can put those in your mathematical vocabulary. When they say complementary, it simply means addition of angles to 90 degrees. When they say supplementary, it means addition of angles adding up to 180 degrees. Okay, so we say x is equal to 90 degrees minus 73 degrees. Very good, Kia. So what's the value of x then, Kia? What's 90 minus 73?
17.
Awesome. Then I fill in, update my diagram. X is 17, Kia. Okay. Now we are missing y, Kia. So now we can go back to what you had said at the beginning. You said something at the beginning which we can now use, because we now know that this angle is 17 degrees. We want y, and we had established that there was a relationship between the x and the y. You had said, you had come up with it. You had told me that relationship.
Alternate angle.
Yes. So what can I then write here, Kia? Since you're saying alternate angles, the Z shape.
Y is equal
Y, yes, is equal to?
no. Okay? It's equal to, should I have to, no, do I have to like look for the answer first and then give the reason after, or
Yes, yes, definitely. What's the answer first, and then we will state the reason.
73?
Okay, so let's look at the Z shape we were talking about. So this is the Z. Okay, now look at this. You see here? What angle is this? What did we say this angle is equal to? This one. We just found it. It is equal to
90.
This one. Look here. This from here to there is 90 degrees. That is angle A. But there's a small portion here that is X. If you look at your Z shape, your Z is basically covering the angle X only. Look at this. You see the Z?
Yes.
Yes, it's covering the angle X, which is equal to what? We just found what X is. It is equal to
17.
17 degrees. So please take note here. The Z, when we write our Z shape, okay, from this line, we go through the diagonal. We ask ourselves, what angle did we just cover? We covered the 17 degrees. That is our X value. That is the angle, but it is alternate to which angle? Let's go down the diagonal and then complete the Z. What angle now are we talking about here? Which angle here?
Why?
It's Y. Are you with me?
Yes.
Yes, because from here all the way down to here, that's 90 degrees. But remember, the 90 degrees is the total angle, but Y is part of the angle, okay? So what are we going to say Y is equal to? Y is equal to what, Kia? Because remember our Z shape angles, if we have a Z shape, we say this angle is equal to that one. If we have a Z shape, we say this angle is equal to that one. So in this situation, Z shape, this angle, which is X, which we said is equal to who? 17 degrees, is equal to which angle? It's equal to which letter? It's equal to?
Why?
Yeah. So Y is equal to 17 degrees. I want you to note this Z shape that you speak about. If the lines are parallel, then these alternative, we call them alternate angles, all right? They are equal if the lines are parallel. So we learned that AD is parallel to BC. You can see the arrows. And AB is parallel to CD. You can see the double arrows, okay? So that means these angles, 17 degrees, which stands for X, and this Y value, those two angles are equal. So Y is equal to 17 degrees. That's why it was important for us to first find X, then we could state what Y is, all right?
Yes.
Yeah, so what is the reason for saying Y is equal to 17 degrees?
Alternate angles.
Exactly. So for short, we say alt angles. We use the symbol for angles, and then we state the lines that are parallel. Which lines are parallel, Kia?
AC. Yeah?
Hey,
No.
please be careful. Which lines are parallel?
AB is parallel to DC.
Which one?
Oh, no, AD and BC.
Okay. Okay. And there's a reason why you say AD is parallel to BC. It's because your Z, remember your Z? Yeah, AD, we passed through AD, then through the diagonal, then we passed BC. You see? Yeah, so your Z shape, where your Z, your horizontal or vertical lines, where your Z is formed, those two lines, AD is parallel to BC. So that's 100% correct. Okay.
Yes.
Okay. Any questions here, like specifically, any specific questions that you have about what we just did here in this problem? Is there something that maybe is not as clear for you that you need a bit of clarity about?
But I thought the the like the parallel lines were AB and DC because like what do those arrows mean like between DC?
Yes. Okay, so take note. If we had used, let's say for instance, we had been asked to find, let's say there was a Z here. Let's just say for instance, for argument's sake, let's say there was a Z and they asked us to find Z. Then we would use, which Z would we use to be for the Z shape? Which Z shape? We would use this one. Are you with me, Kia?
Yes, sir.
Because this 73 degrees is the alternative angle to this letter Z. That's where we would say Z is equal to 73 degrees, but then which lines would we be saying are parallel? We would say AB is parallel to CD. Are you with me?
Yes.
Yeah, but because we were wanting the value of Y, our Z shape, we have X here, which is 17. Our Z shape, here it is. You see, we are passing through AD, through the diagonal, passing through BC. So that's why we say AD is parallel to BC. We can't say for Y is equal to 17 degrees, we can't say AB is parallel to DC. We did not use that for our Z shape. We used this for our Z shape. So we must identify those lines as being the lines that are parallel.
Okay,
Yeah.
understood.
So it's very important that you be specific, because if you identify the wrong lines parallel, you may lose a mark because it means you are not aware of what you are actually doing. Okay. Sorted?
Yes, sir.
Okay. All right. Okay. Let's do I think one last one, and then I'll leave you some to actually do for yourself, by way of, like, you could say homework if you want to say put it that way. um I'll give you a variety. Let's look at this last one here. I think we have at least spent a bit of time with parallel lines and so forth. So here we have A, B, C, D. We are told find X, giving reasons. And I'm sure you're looking at this one and you're like, eh. And then this one, what's happening here? If I was to ask you, Kia, what quadrilateral is this? Would you be able to tell me what quadrilateral it is?
Trapezium.
Yeah, it kind of looks like it, right? But it actually isn't a trapezium. So this is just a random quadrilateral. This is just a random four-sided shape. Because here AB, we are not given that AB is parallel to DC. This is just a four-sided shape. It's a random four-sided shape. Okay, so ABCD is just a quadrilateral. Okay, and by quadrilateral we mean it's a four-sided shape. And of course it is a four-sided shape, just that we don't know what type of four-sided shape it actually is. Now we are wanting the value of X. My dearest Kia, how are we going to find X? What things are we given in the diagram? We are given the angle A, the angle B, the angle C, the angle D. Our angle A is given, and this is the wording, it's given in terms of X. Our angle B is given in terms of X. Our angle D and angle C are actual angles. They have numerical values. So my then question to you is, how are we going to find X if we are given these four angles, two of them being unknown? Is there anything that you are thinking of, Kia? Okay.
No, sir.
All right. So here's the thing. If you look at the comment section there, there's a guy called Ngutuku who has just commented and said, add the angles and equate to 360 degrees. Do you see that comment?
Yes, sir.
All right. Very important comment there from that young man. Very critical comment, that one. Very key. Very key. So there's something I wanted to just say here. The sum of the interior angles of any quadrilateral is 360 degrees. Are you with me, Kia?
Yes.
This is something else that you need to know as part of your properties. Any quadrilateral, Kia, if you add the four angles, if those four angles are there and you can see them, adding those four angles for a quadrilateral should give you a total sum of 360. Okay, are we together? So we
Yes,
need
sir.
to write this down somewhere so that you don't ever forget it. The sum of the interior angles. By that, you mean all the angles of a quadrilateral summed up together, the interior angles. That means this entire angle plus this entire angle plus this entire angle plus this entire angle. When you add those four angles together, you should get 360 degrees. Okay. That is a property for the books. Right? Knowing that helps you out a lot with certain problems that have to do with quadrilaterals. Okay. Had you learned that at school, Kia? I'm sure you had.
Yes.
Yeah, I'm sure you did. Like, there's no doubt about it. But now it's something that you need to know, and your mind and heart needs to know it. What's your favorite music, Kia? Do you have a favorite artist? Favorite music? Favorite artist?
Yeah, I think I do. Yeah.
So what kind of music do you like? And who's your favorite artist at the moment?
It's a little TJ.
Oh, okay, okay. And what do you have a specific track that you like that Lil TJ sings?
Hip hop.
Like, is there a specific song track that you like at the moment?
Um.
The name of the song type thing.
Yes.
Oh,
Yeah.
what is the name of the song?
It's you I forgot the name. But I know it. I know it. I didn't like. It's been a long time since I've listened to his music, so I've.
Oh, okay, it's been a long time. But can I ask this question? And I like the fact that you are saying to me it's been a long time since you've listened to the music. Could you say maybe 2 weeks, 3 weeks, a month has passed? 2 months maybe? 3 months maybe? A year maybe?
2 months.
2 months, eh? Okay, that's quite a long time. But Kia, if I was to put on that song right now, like the one that you like the most,
Yes.
2 months ago, could you sing that song like off the top of your head without looking at the lyrics?
Yes.
Like, and if I was to play the song right now, even though it's been 2 months that you've sang that song, would you be able to sort of like sing it verbatim off the top of your head from your heart?
Yes.
Ah, you see what I mean? So if that is the case, then Kia, my million-dollar question to you is if you learned this particular theory concepts in mathematics, let's say last term, which was just a few weeks ago, and you even wrote a final exam, a controlled test even, okay, why is it that you can't have the same passion, to sort of like remember these important concepts. Mind you, Kia, these very concepts are the very concepts which will either lead to you getting good marks for maths or poor marks for maths. Ultimately, they will even either close or open doors for your future when it comes to whatever career path you want to take, and even possibly whatever future course you want to take in university. So if it's that important to you, then I think just as the song, I mean, the song will not open doors for you. Little TJ's song is not going to open doors for you, but the way you love it, the way you sing it. If I drop I mean, even if I do the opening line of that song, you'll probably be hopping onto that song and singing it for days. So what I want to say is that try and value these little concepts, because I'm sure it's not a nice feeling after a term to write a control test, get the report card back, and you're like, "Ish, these marks. I, ish, ish, these ones. It's not a nice feeling. So you want to have a nice feeling, right? So what I'm saying is, let's put the same passion and zeal. 2 months ago, you said you last listened to those songs 2 months ago. But if I drop the song right now, the way you are going to be singing along, it's crazy. Okay. So in the same way, these things that we are covering here with your properties, you need to know your properties well. You need to know your properties off by heart. And if you do, what's going to happen is that the minute you see a problem, the properties will jump at you. You'll be like, oof, I know what I need to do there. There's nothing as sweet in mathematics here than to know your work and to know what you need to do whenever you are faced with a problem. So that's just something I wanted to say. So don't forget little TJ, don't forget those lyrics, but at the same time, don't forget what we've been able to go through where quadrilaterals are concerned. Because in our next session, I'm going to leave quadrilaterals, hopefully, because I think at least we've established a lot of good ground so that we can move into the other part you wanted to have covered, which is volume and stuff and area and so forth. We'll look at that the next time. So this one, let's just answer this question, and then I'll leave you with some challenge questions so that you can do that, and then I'll see you again. Same time, same place, same situation tomorrow. Okay, so 3x, 2x, 75 and 85 degrees. We just learned that the sum of those interior angles of a quadrilateral is 360 degrees. I appreciate your comment, by the way, Coco. Thank you for the comment. Love my teaching style. Really appreciate it. I thank God for that. So can we then establish, what do we do here? Here we've established that the interior angles, the sum is 360. So what do?
We add the given
Amen. Add them. So let's go. I'm doing it. 3x plus 2x plus 75 degrees plus 85 degrees is equal to 360 degrees. Reason?
Sum of any quadrilaterals.
Sum of angles in a quad equal to 360 degrees. That should be fine enough. Sum of angles in quad equal to 360 degrees. And then let's do our mathematical solving here. We've got a linear equation. I think grade 8 we did linear equations. We were very good. We sorted it out. So we add the like terms. You see 3x and 2x are like terms. We get 3x plus 2x gives us what, Kia?
5x.
Yes, 5x. It's like saying 5 oranges plus 2. I think like 3 oranges plus 2 oranges gives us 5 oranges. So x is like, this unknown variable. It's x is basically denoting something we do not know. All right. Plus 75 plus 85.
160.
Amen. Kia. Hi. Yeah. All right, then 5x. We isolate 160 crosses over Jordan. So 360, which is positive, when he crosses over Jordan, the inverse of positive 160, negative 160. We transpose 160. Becomes negative 160. Okay? Then what's 360 minus 160?
It's 200.
200. Amen. Then after that, we want to solve for x. 5 is a coefficient of x. We call this a coefficient, by the way, the number before a variable. It is currently having a relationship with x of multiply. We want to say goodbye to the 5 because the 5 is multiplied to the x. So how do we get rid of the 5? If the 5 is multiplied to the x, we use the inverse of multiplication. We then divide by what? By 5. But what we do on the left, we must do where?
On the right.
Amen. Then our x value is what? 200 divided by 5 gives us
40.
40. Amen. There it is. Yes. Who said you can't find the value of it? Okay. Okay, any questions there?
This it's just like too complicated, this one, but I'll have to maybe.
Can I ask what part of it is complicated? Is it the statement that was complicated? Adding the angles? Was it that part that's
The
complicated?
2x and the 5x.
Okay.
No, the 2x and the 3x. That's weird. Like, I started, like, from the beginning, I was just confused.
Okay. All right. So Kia, please remember this angle A is 3x. Do we know what the value of x is yet?
No?
No. This angle here is 2x. Do we know what the angle x is? No. This here is 75 degrees. We are given the actual angle, which is 100% sweet because it means we know what angle D is. We know what angle C is. We know them without a shadow of doubt. But now the question is, what is the relationship that exists between these four angles of this quadrilateral? The relationship is one of the sum of these four angles. They give me 360 because we learned that the sum of the interior angles of any quadrilateral is 360 degrees. So then, of course, what do? Take all four of the angles and do what? Summate them, total them, add them together. 3x, here he is. 2x, here he is. 75, there he is. 85, there he is. We then say this sum of angles is equal to what? 360. So we have a statement. Do you understand the statement? And do you understand it being equal to 360? Are we fine with the statement, Kia?
Yes.
Then our reason. Are you fine with the reason, Kia?
Yes.
Okay. Then, Kia, if you are fine, Gengoku, with the reason, the next thing, this is grade 9, guys, and I am currently conversating with a student that is doing IEP, which is like so amazing. Yeah, this is an IEP student. So then after that, the statement and the reason, Kia, we can then go ahead and add. Because remember, we add like terms. I'm sure in grade 8 you guys were able to learn about addition and subtraction of like terms. We can add like terms. What do we mean by like terms? Like terms are those terms that have the same variable. Variable means the letter. So x here and x have the same variable. Okay, are you with me?
Yes, sir.
No, Nino. We can't say the opposite sides of a quad are supplementary. No, Nino Masuku. No, we can't say that. Okay, this is a quadrilateral. It's not a cyclic quad, it's a quadrilateral. So 3x plus 2x, okay, Kia,
5x.
yeah, we can add these like terms. 75 and 85, these are also like terms, all right? So I'm just going to put a circle around them because in algebra expressions, we learn that we can only add like terms. We cannot add unlike terms. So 3x plus 2x, like you said, is 5x here. You're 100% spot on because the addition of these two like can be added. 75 and 85, they are numerical angles. We can add them together. They give us 160. Okay?
Yes, sir.
Yes. Then, Kia, after that, Kingoku, we say 5x plus 160 is equal to 360. We want to find the value of x. So, two terms on the left, one term on the right. We want to then find x. So we need to obviously use our understanding of what we did last year. I think when you were in grade 8, you learned how to solve for an unknown variable, solve for x, solve for the missing letter. I don't know if you guys did that last year. Is it something you've done already this year as well? Or
We did it last year.
Yes. Okay. Yeah. So 160 is added to 5x. Okay. I like what somebody said in the comment section. Okay. We tend to say we transpose the term. Okay. Transposing the term is also a concept. The concept behind transposing, it's like plus 160. You want to get rid of plus 160, but it's plus 160. So to get rid of plus 160, what do you do on the left? You subtract this 160 from this 160. But what you do on the left, you would do on the right. Okay. But for short, we just say take the number, it crosses over, the sign changes. Okay, that's just a short way, a shortcut method of basically saying we subtract 160 on both sides. Because remember, if you subtract 160 here, what's 160 minus 160? It gives you 0. That's why you're left with 5x alone. But if you subtract 160 as well on the right, that means you say 360 minus 160, which gives you 200. Okay. So are we together here, Ria, or is there some Kia, or is there something that you feel like also you don't understand? Let's say in this step, these 2 steps, these 2 steps,
I think
are we moving together for these 2 steps?
yes, I get them.
Okay, then we get here, Kia. 360 minus 160 gives us 200. Now we have 5x, which is equal to 200. This 5 and this x, they are combined together. But what you need to ask yourself is what combines 5 and the x? Okay, 5 and the x, it's like 5 and x, they are multiplied together. So it's like saying 5 times x. That's what combines the 5 and the x. It's multiplication. Okay?
Yes.
Then you have 200 on the other side. So what I said is that we use the inverse of multiplication, which is division. The opposite of, when I say inverse, I'm saying the opposite of multiply. The opposite of multiply is divide. So that's why I said to you, you divide both sides. Remember, we want x at the end of the day. 5 is in the way, and 5 is multiplied to x. So how do we get rid of this 5? We use the opposite operation of multiplication, and we divide by the same number. Okay?
Yes.
Yeah, so we divide by 5. But the thing in maths with equations says if we do one thing on the left, we must do the same thing on the right. You know? So the reason for dividing by 5 is because there's a relationship between 5 and x, which is multiply. So in order to get rid of the 5 here, we must divide. We use the opposite of multiplication, which is division. Division is the opposite of multiplication. Multiplication is the opposite of division. So what we do is we divide by 5, but we do it both sides. So that's why we get an answer of x is equal to 40 degrees.
I think I get it now.
Yeah. Someone else would say 5 times what gives you 200? And I'm sure you can see more. 5 times what gives you 400? It's 40. Okay. Another way of looking at it is saying 200 divided by 5. What does 200 divided by 5 give you? If you want to know the specific answer, you know, because this is multiplication, this is multiplication. The opposite operation of multiplication is divide. So you can say 200 divided by 5. You will get what the answer is here. 200 divided by 5 gives you 40. But you see now, this is just a mathematical procedure that we can use to get the answer using these steps. So 5 times x is 5x. We always take whatever the coefficient or the number before the variable is. Whenever the variable is isolated with the coefficient, we take whatever that number is, we divide by it. But we do it both sides, and then we get the answer. If there was a negative 5x on the left, we would divide by a negative 5, both sides. Since it's a positive 5 that we are multiplying with, we divide by a positive 5. Okay?
Yes, sir.
Yeah, so our x value is 40 degrees. Done and dusted. So, Kia, I hope that was a fruitful, session for you. So now I'm going to leave you with some, I call them game challenge problems. I don't call them homework. It's called game challenges. So I'll just leave you some game challenge problems here, and then call it a day. Okay, so you don't do these now. You can just take them down, or you can screenshot them, whatever is easier for you. I think screenshotting nowadays is easier because then you can. Okay. Okay, so for this problem, this is a rhombus. ABCD is a rhombus. You are given this angle here, which is 34 degrees. Then we are asked to find y, and you are asked to find x. Okay, remember this is a rhombus. Rhombus. Okay, so I'm going to do the corrections tomorrow when I have the session with you, okay? But I'm going to leave these for you to do. First thing, before me and you jump into volume, which is what you wanted to do as well. Okay, this is a kite. The angle here is 52 degrees. Okay, LMN is a kite. So here we want to find x and y, and we need to give reasons. Okay. Okay, can you see this diagram? Well, 65 degrees, that's 52 degrees, okay? Good?
Yes.
Okay, I'm just gonna do another one, and then we'll call that a cap. Y, X, 5, 4, A, B, D, C. Okay. Honestly, now we're reverting back to sides. We are told that A to CD is a palm parallelogram. E, Q, S, R, that, X and Y. So we are told PQRS is a palm. So I use palm for short, parallelogram. This is a palm. PR is equal to 5 centimeters, and QS is 3 centimeters. And what you want to find is X and Y. Okay. Yeah, and by the way, X is the length from here to there. Y is the length from here to there, right? Okay, there's something to note about that X and that Y. Okay, but you are given that PR, the full length is 5, QS, the full length is 3. So they want you to find Y and X. Okay. Okay, can I move on to writing the last one for you?
Yes, sir.
Okay, and then the very last one. Okay. DEFG. This is x plus 30 degrees. This is x. Okay. Euclidean geometry for grade 9. DEFG is a trapezium. So in the same way, they want you to find the value of x, giving reasons.
Thank you, sir.
All right. Thank you so much as well, Kia. It's quite a lengthy meal, if you ask me. It's like a buffet of sorts. Okay. It's like a very long buffet of geometry. Hopefully it's really getting to you. I think little TJ will be very proud of you when he hears that you are doing your things in maths. Oh man, okay. Thank you.
Bye, sir.
So we'll see you again same time. Is it 6 tomorrow? Okay. Hi, Bo. Yes, Sabrina. Yesterday we had grade 10 game. But the thing is, Sabrina, you are talking specifically about the Euclidean geometry. Smonello, the grade 11 term 2 topics are, you will be doing grade 11 functions. Grade 11 functions. So you have functions, you have analytical geometry, and you have Euclidean geometry. Okay, that's grade 11 term 2 topics. Okay, if you go to my YouTube channel, I've posted the introduction video for Euclidean geometry for grade 11. I did 2 theorems a few days back, so you can check out my video that I've posted there on YouTube for grade 11. You can find the bio in the link in my bio for the YouTube channel if you don't know that already. Then functions. I also started functions. I did a session on linear functions, straight line functions, and then I did a session on quadratic functions. So there's 2 videos that I've posted up for functions. The most recent videos that I've posted on functions, you can check those out too. Okay, so I'm gonna develop each topic for the grade 11s one bit at a time. There's game challenges I left as well for those 2 sessions, so you can check that out too. Not that guy. Guys, I'm actually going to be abandoning the session for grade 10 that I was supposed to do, because you can see I had a live private session here. Guys, I do live private sessions where I answer specific questions from learners directly. But those are obviously, like, we've arranged with the parent, for instance, that we can do that. And then obviously there is a certain amount that's attached to that. It's not something that I do freely. Because, for instance, that specific learner that I just had a conversation with is someone that basically said, yo, sir, my term 2 results weren't good. The mother obviously had a conversation with me on the side, and then we were able to make an arrangement. that I do some live sessions. So I obviously it benefits everyone that comes onto the session, but I'm addressing a specific challenge that that learner has, in the content from last term. Okay, like I said, that's a IEB learner, grade 9, that I had a session with just not so long ago. Okay, and yeah, so those are things that I do, but remember that generally the live lessons, when I cover them, they are free for those that join in. But unfortunately, we may be doing a specific thing that you may not feel that you want covered because you feel like you are comfortable in that. So it's actually very preferable that if you want specific things, then we can make a specific arrangement. But like I said, it will cost you. That obviously, because it needs specific preparation. I need to obviously find out what your challenge is, have a conversation with you on the side first, and then arrange, specifically that particular lesson that you'll be covering. Okay, so that was Kia. I think me and Kia, we are done nicely with her. It was nice. It was good. I think in shortly I'm going to be assisting another learner. Another learner wanted assistance, specifically with financial maths. The mother also approached me on the side, wanted assistance financial maths for grade 8. So we'll be doing some grade 8 content for financial maths. Sandile Mbele, do you only cover maths only? Yes. The thing is, I don't want to be all over the show, Sandile. I could cover a whole lot more. Like, I major, life science is another major of mine. I am really slowly but surely getting myself into the science sort of like perspective as well. So, but for now, okay, because for the maths, I'm sure about. I'm doing only the maths for now. In the future, maybe we'll have the cousin brother to maths as a game. Maybe in the future we'll have the cousin brother and then the cousin sister to maths as a game, which is something else. So we are playing the maths, we are showcasing the maths, we are doing all sorts of things with the maths. Sabrina, I will obviously do a session. You followed me most. I'll be doing a session with what I did with you guys. So we'll wrap that up. Okay, we'll definitely wrap that up at some point, because for the grade 10 Euclidean geometry, seems like you enjoyed that session, didn't you? Now you're back for more. Okay, guys, I'm gonna end this live session because I need to record.